Hello students, good evening students. Today our topic is dipole moment based students. In previous videos on dipole moment, I already explained you, but based on the previous questions, once again I want to explain. Look at this. 24, 23, 22, 21 number of questions are there students in the mains examination, and also NEET examination point of view also it is important, but mains examination point of view in the 24 year more than I think more than 5 questions are came, all the phases based. Dipole moment based polar molecule and non-polar molecules, zero dipole moment, non-zero dipole moment molecules they are asked. In the previous video I already explained you this data. Dipole moment not equal to 0, that is polar molecule. Dipole moment equal to 0, that is non-polar molecule. This values depends upon not equal to 0 or equal to 0 depends on what? Shape of the molecule is the deciding factor. Once again look at the shapes of the molecules identification. If you have get clarity on the shape of the molecules, if you get clarity, identification of dipole moment is easy. Is the polar molecule or non-polar molecule? Few examples I am giving now. BeCl2, CO2, BF3, NH3, methane, PCl5, SiF4, H2, CHCl3, CH2, Cl2, BeF2 or BeCl2, HF. So different molecules are there, many examples are there. Look at the one by one molecule, the shapes of the molecules. If you know the shapes of the molecules, dipole moment understanding is easy. And polar molecule and non-polar molecule, we are easily predicting that. BeCl2. What is the shape of the BeCl2? If you want to know the shape of the molecule, compulsory in the molecule, what is the central atom? That identification is needed. What is the central atom here? Beryllium. What is the central atom? Carbon. Here boron, nitrogen, methane, phosphorus. These are the central atoms. In this molecule BeCl2, beryllium is the central atom. Group number is secondary group element. Valency electrons 2. I am writing these valency electrons 2 like this. Around the beryllium 2 chlorine atoms are present. The 2 chlorine atoms are each chlorine 7 valence electron, group number is 7. Here existing like that. The 7th electron overlap with beryllium electron. The 7th electron overlap with beryllium electron. Now what is the hybridization? Hybridization starts with s orbital. Generally which orbital is present first? S orbital. So this is S, so this is P. What is the hybridization here? SP hybridization. SP hybridization means what is the shape of the molecule? Linear. What is the shape of the molecule? Linear. BeCl2 existing linear arrangement like this. Beryllium and chlorine, which is more electronegative element? Chlorine. So sigma bonding electrons moving chlorine side. This is the representation of the dipole moment. Beryllium gets positive charge. The sigma bonding electrons moving chlorine side. So the both movement of the electrons oppositely existing exactly to each other. So what is the dipole moment here? 0. Both are cancellation to each other. So linear molecule, dipole moment value 0. CO2 molecule. CO2, carbon dioxide. Carbon dioxide, what is the central atom? Carbon. Group number 4. Valence electrons 4. 1, 2, 3, 4. Generally in the bonding, carbon takes how many, oxygen takes how many electrons? 2 electrons. Already in the valency shell of oxygen, how many electrons are present? 6 electrons are present. For developing octet, how many electrons are needed? 2 electrons are needed. That's why it takes 2 electrons in the bonding oxygen. So what is the hybridization here? This is S, this is P. So hybridization is sp hybridization. Sp hybridization. Boron trifluoride. Now sp hybridization means what is the shape of the molecule? Linear. This is moving this direction, this is moving this direction. Dipole moment value 0. Linear molecule dipole moment value 0. Next molecule BF3. Central atom is boron. Group number, third A group element. Valence electrons 3. Around the boron 3 fluorines are there. Here the fluorine electron overlap with boron electron. Observe the hybridization here. S, P1, P2. What is the hybridization? sp2 hybridization. Total pairs 3, bond pairs 3, lone pair 0. In this condition, trigonal planar. Trigonal planar. Trigonal planar arrangement. Fluorine, fluorine, the fluorine. Here the boron and fluorine. Fluorine is the more electronegative element. The sigma bonding electrons moving fluorine side. This fluorine electrons this direction, this fluorine electron this direction. Both the bonds result in dipole moment this direction. Result in dipole moment. And both are opposite to each other. There is a cancellation. Dipole moment 0. Boron trifluoride dipole moment is 0. Boron trifluoride is planar molecule, students. Planar molecule. Planar molecule surrounding atoms are same. Dipole moment is generally 0. Planar molecule means all the atoms are existing in the same plane. Dipole moment is 0. Next molecule, what is the next molecule? Ammonia. Ammonia, what is the central atom in the ammonia? Nitrogen. Group number 5. Valence electrons 5. 1, 2, 3, 4, 5. Around the nitrogen, 3 hydrogens are available. Each hydrogen electron overlap with nitrogen electron. So here the one lone pair is there. So here S, P1, P2, P3. What is the hybridization here? sp3 hybridization. Total pairs 4. 1, 2, 3, 4. Bond pairs 3. 1, 2, 3. Lone pair is 1. In this condition, what is the shape of the molecule? Pyramidal. What is the shape of the molecule? Pyramidal. Shapes also, yesterday video I shown you. Once look at the shapes of the molecules also, students. Here ammonia is the pyramidal arrangement. Here nitrogen, hydrogen bond, nitrogen, hydrogen bond, nitrogen, hydrogen bond existing like that. Like a Egypt pyramid arrangement. On the nitrogen, lone pair is present. The lone pair is existing like this. So compared to hydrogen, nitrogen is the more electronegative element. The sigma bonding electrons moving towards the nitrogen side only. The overall electron density moving nitrogen side. There is no any cancellation. Dipole moment in these cases not equal to 0. So ammonia NH3 dipole moment not equal to 0. What is the another example? CH4.